Thank you. Well, good morning, everyone. I am so thrilled to be kicking off what I'm sure will be an absolutely fantastic Serverless Days Cardiff. So thank you so much, everybody, for taking time and coming out to join us. As Matt mentioned, for those of you that I haven't gotten a chance to meet yet, my name is Emily Shea, and I'm the head of Serverless Go-to-Market at AWS. I've been at AWS for about 8 years now, mostly in various serverless business development capacities. And so I've really gotten a chance to get to feel how fantastic the serverless community is. And I always appreciate the opportunity to come out and speak to you folks. As I was preparing for this talk, I was thinking back to my first serverless-focused conference that I ever went to, which was back in 2019 in New York City. That was Serverless Conf. And I remember this was a really fantastic experience because it was my first opportunity to get out and to see the community in action and get to meet people, and that was amazing. I do remember that I think one of my important duties that week was helping Chris Munns to unbox socks. So I think we've been on a journey, and I'm excited to still be part of the community and getting to do cool stuff with you all. As I was thinking about this, I was also preparing and thinking a bit back to the history and the journey of serverless at AWS through time. And especially this is relevant because this is a particularly significant year for AWS serverless. So of course, if we want to think back to the history of serverless at AWS, we have to go all the way back to the very first services that AWS launched, which were serverless in their operating model of S3 and SQS. Then we had serverless databases with DynamoDB, and of course, serverless compute with Lambda functions. Shortly followed by the ability to host APIs and to run containers in a serverless way with Fargate. And lastly, with some of those application integration services, serverless workflows with step functions and EventBridge for event buses, which was also back in 2019 a launch that I got a chance to be a part of. And the exciting thing that we're celebrating this year is the fact that it's actually been 10 years since 2014 when Lambda was launched, which is really incredible to think that we've had AWS Lambda, which a lot of people think of as kind of the core of serverless application development, and in a lot of ways synonymous with serverless, around for 10 years. That's been 10 years of product development and feature releases and listening to you all as customers to try to make that service even better. But also, more importantly, it's 10 years of seeing the incredibly cool things that customers are able to build with serverless and build with Lambda, and the potential that they're able to unlock with the serverless, everything that serverless makes possible. And so with that, and kind of this 10-year anniversary, I've been thinking a bit about what does it really mean to build serverless in 2024. So what has changed in the decades since we've been working on products and customers have been building things, and what's really remained the same and what's still fundamentally true. The first thing that I think about is the fact that serverless services are really foundational to a lot of the ways that customers are building on AWS and building cloud-native applications. We can see this in the numbers when you think about the fact that there's over 2.5 trillion events delivered by EventBridge per month. Lambda is processing over 10 trillion requests every month. A million API gateway APIs are hosted, and also billions of workflow executions with step functions are happening daily. So there's a huge amount of customers that are taking advantage of serverless services. I also think about this when I think about the AI/ML stuff that's coming out. I don't know if anybody has noticed, but we are in a bit of an era of AI/ML at the moment. And so, of course, there's been a lot of cool new services that are coming out around this. And if I think about some of the newer ones, like Bedrock, but also some of the ones from recent years with TextTrack and Recognition, all of these are launched with a serverless operating model with the goal of allowing customers to use AI/ML models without needing to spin up infrastructure or train their own models, but instead have an API that they can use to be able to start taking advantage of that right away. So there's something very serverless in the way that a lot of these services are being constructed. However, the other thing that strikes me as very cool about this is the fact that as we're seeing more and more AI/ML applications built, we're seeing that customers are turning to the serverless application development services to build those applications. So whether that's a use case like calling a model endpoint asynchronously, or creating a workflow to orchestrate multiple steps of a process that uses AI/ML, we're finding that lots of customers are reaching for those serverless services as they go to construct these architectures. One of the cool stories that stood out to me, and this was when I was attending the London Summit earlier this year, is from the TUI group. So this is their CIO talking about the SEO optimized content generation process that they built. And what they did with this is they obviously needed to build this very quickly. All these technologies had just recently come out, and they wanted to start to build with it. And so they built a step functions workflow. And that workflow coordinates a number of Lambda functions, and they wanted to be able to call multiple models. So they call one model to generate some content, but then they like how another model actually formats that content and takes that output and makes it ready to be able to post. And so there's a number of things that are being coordinated by the serverless services within this. And I think that this is just one example of what we're seeing customers do as they think about what's the fastest way that I can start to use AIML and start to see what potential it has in my applications. They turn to serverless services, which have those native integrations and the operating model that functions really well with what they're trying to build. Something that has kind of struck me as I've been talking to customers that are doing this is the fact that the technology landscape and the cool innovation that's coming out is always going to be changing. And that's one of the things that I think I definitely love about being in the technology industry is the fact that it does move so fast and there's always something new coming out. But the thing that really hasn't changed and what continues to be even more true is the fact that faster time to market is so critical as people are looking to take advantage of whatever's newest and get that out there quickly. And we're finding that customers are able to use serverless services to be able to experiment and get things out to production incredibly quickly. And that continues to be true and a core goal of serverless on AWS today. Another thing that I think about, and that's an important trend to be thinking about in 2024, is the fact that serverless applications are often coexisting in a landscape within an organization that has lots of different technology choices, or a heterogeneous environment of technology in the mix in an organization. And so what I mean by this, and you might be familiar with this scenario, is maybe your team is building a serverless application. And you are in an organization, probably unless you're in a kind of a startup that's building something entirely new and getting to start completely from the ground up, there's likely going to be some existing systems that you need to connect with and integrate with. Maybe those are running on-prem or somewhere else, but you need to pull in events or data from that system or make updates to that system. And so that's something that you need to integrate with. Maybe there's also some applications that you have recently moved from on-prem, but it really wasn't worth the kind of effort to go back and refactor all of that. And so you just took that and lift and shifted that to EC2. And that's another piece that your serverless application is going to need to communicate with. There might also be a team that has chosen to build things on containers. Maybe that's based on a technology preference or a workload characteristic that this makes a lot of sense for. And so that's another group that you might need to be communicating with. And lastly, there might also be SaaS applications that are in the mix that you're needing to integrate with or process events from. And all of this makes up the kind of diverse technology landscape within a large organization. And so it's important that we talk about kind of the reality of where serverless applications are needing to coexist amongst all these other options and how that works and how to choose kind of the right technology and the right tool for the right job. And the last piece that I think about of what's really crucial to building serverless applications and what's very true about serverless in 2024 is that serverless really shines at enabling evolutionary architectures. And to explain by what I mean by that, I'm going to use the definition of kind of evolutionary that Dave Boyne presented at London Go-To EDA Day earlier this year. And so the way that we can think about this is that when you're going out to build a brand new system, say you're at the very beginning, you know that your understanding of that system, what that system needs to accomplish, the requirements of it, the domain, your knowledge about all of that is going to increase over time as you start to get your hands dirty and experiment and try new things. However, the unfortunate part about it is the fact that right at the beginning of starting to build that application, you're probably making all of the crucial decisions up front, and those are kind of the biggest ones that'll set what's true, like the design of that application, the system, all of that gets, those choices are made up front, and you don't get to take advantage of the later knowledge that you have as you continue to experiment and learn. And this creates a bit of a paradox about those big decisions getting made up front and kind of locked in, and preventing you from evolving that application as your knowledge of the domain and of the problem space grows. Now, one thing that you can do to avoid this is find a way to build an architecture that is set up to evolve, that is set up to change as you learn more, and defer those decisions. Push those decisions out so that you're able to continue to evolve that application as its needs change and as you learn and as you know a lot more about what you were trying to achieve. And in this way, we find that serverless is really exceptional for helping you to build evolutionary architectures. From enabling you to experiment without needing to spend a bunch of investment and time up front spinning up and managing infrastructure, allowing you to spend less time writing or maintaining code that is undifferentiated and make use of more built-in features and more services that allow you to get up and running faster. And of course, building event-driven architectures. So a lot of these services are emitting events by default, or they're easy for you to start creating your own events and be able to build and evolve from there. And so this is the topic that we're going to spend a fair amount of time on in this talk today. I've already mentioned my name, and I'm going to be focusing a bit on the kind of background of the problem, and then I'm also going to talk a little bit about some more of the reasons why you'd want to evolve your architectures, and also touch on some examples and some patterns that we see customers doing when it comes to changing their architecture. And then shortly after that, I will be joined by Tom Collins, who's a principal software engineer at the Driver and Vehicle Licensing Agency in the UK. And Tom is going to share some really cool stuff that they are building at DVLA and that really exemplifies a lot of these things that we're talking about in the talk. So with that, let's jump into a bit more about why you would evolve your serverless architectures. So we've talked a bit already about the fact that your application needs evolve. Maybe your knowledge of the system evolves, or what the application needs to accomplish is changing. Some other reasons that you might want to evolve your serverless architectures would be to leverage platform capability. And what that means is that maybe you have maybe you're spending time coding something or building something yourself, where you could actually take advantage of something that's baked into an AWS serverless service today, and give that over to the platform to manage and maintain and scale for you. Another piece of evolving architectures is to improve the runtime characteristics of that application. So maybe it's reducing the latency or improving the way the application scales, something that makes that application more effective and more efficient. And lastly, and an all-important one that I think can be embedded in all of those, is just reducing the cost and complexity of running your application. So we will jump into each of these in a pattern catalog, and just talk about some of the examples about how customers are accomplishing this. So the first off, around when your application needs evolve, a good example of this is moving from point-to-point messaging to an event routing pattern. So maybe when you first get started building an application, you have maybe a system A and a system B that need to communicate with one another. Now, a very quick and simple way to do this is to set up a queue and to have point-to-point messaging between A and B. This is an effective way to have those systems be decoupled, but still able to interact with one another, and it's a simple and straightforward way to get going with that. Now imagine that the system grows in complexity, and now you have multiple consumers that want to get those messages. If they all want the exact same message, you could use a fan-out pattern, but if those consumers want maybe different messages or want to pick and choose what they want to listen for, then you might need a little bit to change this pattern a bit. You also might have multiple producers that are now entering the system. And for both of these, it can be helpful to do a event routing pattern in which the producers can emit events and not be concerned about who is listening on the other side or need to know details about them. And the consumers can subscribe to whatever events that are interesting to them. Some other examples, maybe you start out writing your business logic with function code, and then as it gets more complex and you think, oh, I want to actually be able to change this or have some branching logic within that, it might make sense to then move to defining your business logic through a workflow that you can more easily visualize and edit and debug individual steps. You also might move from object storage to a database like DynamoDB as again, the application needs become more complex over time. The next category of patterns is around leveraging platform capabilities, so taking more advantage of what's built in as features in AWS services. One of these could be maybe you start off writing code to call a service API and running that as Lambda function, and then moving to using a direct service integration. An example of this is take the step functions workflow, for example. So this workflow is calling S3, it's calling textract, and then it's putting that information into DynamoDB. Now this workflow absolutely works. So all of those Lambda functions are set up to use the SDK, maybe Boto 3 with Python, to make those calls to the service APIs. But we can make this even simpler and have less code that you're writing, testing, deploying, by just using the SDK integrations that are baked into step functions to make those API calls for you. Some other ways that you could better leverage platform capabilities would be instead of having consumers that write conditional statements to say, oh, I only want these messages, or if any messages look like this, then throw them out. Instead, you could filter or eliminate unwanted messages maybe at the event bus level or at the event rule level. And then you're able to save yourself even invoking the downstream consumer and eliminate those messages before they even hit that point. Another one is you could go from sending maybe success failure messages manually to instead sending messages automatically through something like Lambda destinations. And the last pattern category that I want to touch on is around improving runtime characteristics. And here's an example in which maybe based on your application characteristics or the best way to work with it, you might move from a choreographic approach to orchestration or from orchestration to choreography. And so to understand a little bit about these two concepts, in a choreographed system, basically what you have is you have events that are free-flowing throughout the system. So there's no centralized control over where this event needs to go or what order steps need to be taken. And this can be super helpful when you want to take a very decoupled approach. So for example, you might have your development team is working on this system, and there's another team way across the organization that is working on another system. And you want to have those systems interact, but you don't really want to spend a lot of time getting to know their system or having to ask them about a change they're making. You want to make that a very decoupled interaction. And so in this way, events can be very helpful. However, one of the challenges of this is that it can be difficult to understand, all right, what's going to happen in a certain order, or how do I figure out kind of where the events are flowing and how things are happening. And if you do want a bit more control and a bit more kind of centralized understanding of what's going on, then it can be helpful to take an orchestrated approach, which often will involve a workflow. And this can be really helpful, say, if you are a single development team that really wants to have a clear understanding of the steps in which things are happening and a clear view for visualizing this, debugging this, then a workflow or an orchestration system can be very helpful. And this is something that, again, as you learn, if you're setting out to design a system, you might not know which of these is going to be the right path for your application up front. And so it's helpful to be able to think about evaluating your application's characteristics as time goes on and moving. I've seen customers move from choreography to orchestration or from orchestration to choreography, depending on how that system that they're trying to build evolves over time. And so that's a great example of kind of evolving with your knowledge as it grows about what you're trying to build. Another example of improving runtime characteristics is potentially you have a system that is set up to poll for responses and to sit there and wait. Whereas instead you could use a wait for callback step in a workflow, which sends a token or waits for a token to be returned and pause the workflow and starts it back up again. And that's a more efficient way rather than continually polling for a response. So that wraps up the kind of introduction and pattern catalog to set up some of the foundation. And now I'm excited to welcome Tom on to talk about all of this in practice at DVLA.
Lovely. Great. Thanks, Emily. Really positive to see so many people here today for this great event. It's a really good day of speakers ahead of you. So, yeah, real good. So my name's Tom Collins. I am Principal Software Engineer at the Driver and Vehicle Licensing Agency, the DVLA. In case you don't know about us, we're part of the UK government. We maintain the UK's records of drivers and vehicles. We collect a lot of revenue, so about 6 billion a year in revenue collected, and we're very early adopters of public cloud, make extensive use of both container and serverless workloads that we've been doing for many years. So I'm going to continue the theme that Emily started, talking about evolution of your serverless architecture in the context of what we do at the DVLA. Going to run through an overview. We're going to put this in the context of our internal application processing platform. I'm going to talk a little bit about evolution and governance, which I'm going to try and make more exciting than it sounds. And we're going to go through some examples at the end. So first up, evolution of technology isn't a particularly new thing. Whilst in modern cloud and serverless, evolution is progressing at a rapid pace. There's new services and new features being released all the time. Technology evolution isn't a new idea. If you look at it through the perspective of the driving license, we've gone from the early days of a paper license through to early computers and things like punch card systems, into an era of mainframes. We've got on-premise systems. We've got movement from paper licenses to photo driving cards. We've got early legacy cloud, and then we've got modern cloud, which is where we are today. So even someone like the DVLA have been evolving our technology for decades and decades. So I mentioned our application processing system. This is something we've built out to support the modernization of our drivers' services. And these are services that let citizens do things like apply for and renew their driving license. Our current systems are built on legacy technology. They look like this, which is it's definitely looking a bit dated. And the technology it's built on and the way it's been, the way we're able to maintain and modify it, limits our ability to meet business change, apply security best practice, and leverage modern cloud. And we're replacing it with brand new shiny UIs, using the GovUK styling so they look and feel like other modern digital services provided by the government. But this is really more than a superficial change at the UI layer. We are fundamentally rewriting and rebuilding both our front end and back end processes to support this. And at a high level, our architecture looks like this. Citizens and our staff access user interface applications running in containerized workloads on EKS. We then have a serverless application processing layer where we make extensive use of step functions, Lambda, DynamoDB, SQS, and other services. And from there, we're able to orchestrate out to other workloads, whether they're container workloads, other serverless utilities, and even things on other cloud like Dynamics 365. And we'll dig into this architecture a little bit later on. So application processing is, for us, it's a big strategic investment in how we can handle online drivers transactions. Currently, the system processes over 1.5 million applications a year, and this number will increase as we support new transaction types. It's currently collecting over 30 million a year in revenue. We launched version 1 of this architecture back in 2021. This was to support a single transaction type. Started using step functions as an orchestrator. We found this was a great fit for the business problems we were trying to solve and the way we wanted to build things. So in 2023, we launched a version 2 architecture. Now, version 2 was designed from the start to take the learnings from version 1, but actually evolve the architecture into something that could support many transaction types. And we also use this as an opportunity to switch accounts into our modern strategic organization account structure. And it's useful to think about evolution. I gave an example there how we've evolved from a version 1 to version 2 architecture. Now, this isn't something you're going to be able to do regularly, right? And it's a unique opportunity when you get the chance to rebuild something or rethink about it or move accounts. It's a unique opportunity to evolve your architecture. And you really want to be thinking about this sort of multi-year strategy and how you get from where you are now to where you want to be or to a better place and keep your systems making best use of modern cloud. So some of the reasons why you may want to evolve your architecture, they can vary. So the obvious reason is functional change, right? You're likely to have a backlog full of business demands to implement new features or update your applications. The complexity of functional change can vary. Some things can be quite straightforward. Some things may take many months or years to build out. An example of functional change might be we want to use some machine learning to process a photo and detect some faces. And there are obvious benefits to functional change. It's very easy to justify because it's what the business need. It might increase your revenue, provide customer satisfaction, that sort of thing. The second type of cause for evolution and change is what I call unavoidable change. These are generally low complexity. And it might be something like you're using Lambda, AWS are going to switch off the Node 16 runtime. You know it's going to happen. You've got no choice but to change your application to meet this, and it's very easy to justify, right? There's huge benefit, it's a good thing, you're going to maintain your application, use a more modern runtime, update your dependencies. You can't not do it because your application will break. And you definitely want to be doing some of this. The third type of change is optimization. This one's a little harder to justify, right? If you're saying we want to do a bunch of work to our application to switch to a new technology or use a new feature, but often there's no immediate business benefit for this sort of change. The benefit is often to engineers, making your application easier to support, maybe some reduction in cost or increase in security, but then this sort of change is going to be competing with the functional demands against your system. And then the fourth type of change is strategic change. And I mentioned how between our version 1 and version 2 architecture, we're able to switch accounts to a modern organization-based account structure with much improved governance and management for within our organization, but it's a highly complex change, right? If you're having to move all of your application from one account to another, maybe move your data from one account to another, and all of the services that integrate with you may have to change the way they integrate. This isn't something you're going to be able to do on a regular basis. It's something that needs to be planned out, maybe a number of years in advance. So when you think about evolution, you're going to want to be doing, you want to be using all of these strategies. You want to be doing something from each row here and really have that sort of perspective. How are we going to get from where we are now to a better place that you want to reach? So back to our application processing. So at the heart of application processing, we utilize step functions. This has allowed us to move from a choreography to an orchestration pattern. Step functions, if you've not used it, it's a visual orchestration language where through infrastructure as code configuration, you can model complex business processes, run things in parallel, integrate with many services. It allows you to reduce cost and complexity. So Amazon run step functions. You don't need to run any infrastructure yourself. And you only really then pay for state transitions within your step functions implementation. And it's also a service that itself evolves. So step functions is constantly being improved with new features. Every time AWS releases a new service, you're able to directly integrate from step functions with that service. And lots of services like Lambda and SQS have optimized and managed integrations in and out of step functions. So one of the business processes we model within step functions is our photo process. When you apply for or renew your driving license, you're required to provide a photo to go on your photo card. We built a serverless image service to support this, so citizens can take a photograph, upload it. This goes into S3. We use S3 object events to trigger a Lambda. From the Lambda, we're able to use Amazon recognition to detect faces within the photo and perform some validation. And then we're able to modify, crop the photo, modify and generate it in various formats and store it in S3. I'm not sure how this guy got there. If any of you recognize Matt, one of the organizers. In this example, Matt's photo, we've used recognition to detect where his face is, and then we're able to crop it and store it in an appropriate format for use on the driving license. So this is a complex business process. And as part of this, we require a human staff member to review each photo. And this is our internal portal. Once your photo is uploaded, step functions will, once it's performed the manipulation, will then put it onto a queue so staff can validate the photo. Once that review has been complete, it may get approved, in which case step functions is told to proceed and will then issue the license and it'll get printed and sent to you. Or it may get rejected because it's not appropriate. And step functions can also manage this business process, maybe notify you, let you know that you need to replace your photo, and wait for you to provide that photo back. So this sort of long-running process, so when we're waiting for a customer to provide a photo, or maybe we're waiting for a photo to be reviewed, this sort of thing is very easy to model within step functions. And as we've evolved to use step functions for this sort of thing, the pattern we use, rather than sort of polling, has this bit of work being done. The pattern we use for this is waiting for a callback. So in this example, you can see that the highlighted step here, we're waiting for a photo to be reviewed. And this may take hours or days. If you upload a photo on a Friday, maybe the staff who review it aren't working till Monday. What step functions will do is automatically pause at this point. We will generate a task token. So as part of our configuration, we'll tell step functions, hey, at this step, I want a token, and I'm gonna call you back later with the token and tell you what the outcome of this long-running process is. And we can pass the token from step functions. It's just a string. You can then take this outside of step functions. Maybe you want to store it in our case, we store it in a task system, but you may have another system. You can store it in a database. You can write it down. It doesn't really matter. You can do the work. You can wait days, weeks to do this, whatever this activity is. Maybe some long compute. Maybe waiting for some people to do some things. And once you've completed that process, you simply need to call back to the step function service and say, hey, for this token, I finished the work. Here's the outcome. And in this case, we've said we've reviewed the image, and the outcome is that it's approved. At which point, step functions will then proceed to the next step. So this is a brilliant pattern. We use it for many, many different things, both human tasks, but also long-running tasks, things like fulfilling an application to our mainframe. We'll send it off and wait for a result back with a token. So drilling into our architecture a little bit more detail. So citizens will use our services through Ruby on Rails-based applications running on EKS. From there, we then integrate into application processing. We use API gateways, land some application data in Dynamo, and then start several step functions processes. Step functions, in addition to managing our human tasks, is brilliant for integrating out to other services. In our case, this could be utility services like sending emails or printing things. It may also mean that we integrate out to our casework systems on Azure and Dynamics. And step functions really at the heart of this, using event-driven compute and managed orchestration allows us to do this in a very flexible way that's easy to evolve and adapt. Once an application is complete, submitted, our internal staff are able to then access internal-facing applications, pull items off queues, and then use the task token callback to complete their review activities. Once an application's been approved and reviewed, we're then able to send it out from step functions through another queue, through a Java adapter, and then ultimately into our driver's mainframe system running outside of AWS. So you can really see step functions at the heart of our system allows us to leverage the best of event-driven compute and managed orchestration to integrate across many, many different workload types and adapt and evolve our business process as we go. Okay, this is the section on autonomy and governance. So we're a large organization. We've got anywhere from 15 to 20 teams working. We have over 150 accounts between production and non-production. We want to be a place where developers can innovate. We want to be able to give teams autonomy, but we're also looking after some very important data for the whole of the UK, and we really care about the security and protecting the data that we build. And these are competing concerns, right? How do we give developers autonomy, make happy developers who can use new services and innovate, but also protect data and do things in a governed way that protects our data. A few of the things I'm going to talk about in this regard are service control policies, IAM permission boundaries, and our use of IAM resource policies. Before I do that, I'm going to use an example. So this is an attempt to make enterprise governance as exciting as we can. It's a real-world example. If you want to make it more exciting, every time I say event bridge pipes, imagine Gen AI. A little bit more fun. Right, so back in December 2022, at reInvent, Event Bridge Pipes was launched. Event Bridge Pipes is a managed integration service that allows you to connect data from one service to another through a managed service that lets you do filtering and optimized integration. It's launched in December. 2022. At this point, we were unable to use event bridge pipes, right? We've got controls and governance in place that stops teams picking random services and using them, which is a good thing to do in government because we want to protect our data. So how do we get from the place where a new service is launched to a point where our teams can start using it and ultimately get this into production? So at the DVLA, all of our technology and services are managed through our enterprise technology catalog. This is a peer-reviewed catalog of services, software, and technology where we're able to add items maybe under a trial status, and maybe adopt things or sort of stop the use of them. And this is peer-reviewed by members from engineering, from our cybersecurity teams, from our architecture teams. So we've really got anything that's in here, we've really gone through the governance process and done our diligence. And by December the 15th, we were able to put a request in to say, actually, there's this new thing, pipes, we'd like to trial it. December 15th, trial event bridge pipes. What this meant is we had the approval necessary to do this in non-production environments. And our cloud team, who manage our centralized policies, in this case, on the same day, were able to update our policies to allow development teams to use pipes in non-production. So this is pretty cool, right? 2 weeks after this thing being launched and announced for the first time, we've updated our governance to support teams using it. Things slowed down slightly because Christmas got in the way, but by January the 6th, we actually had development teams using pipes. So about a month after launch, we started, hey, let's use pipes to solve this particular problem. We can optimize our architecture. Then by March the 30th, so we're talking 4 months, we'd done the development and testing we needed against pipes. We'd gone from a trial to an adoption phase, and we were able to actually put pipes into production, which is 4 months from this thing being launched to being put in production with all of the appropriate enterprise governance, which I think is pretty cool. So how do we do this? At the heart of our governance model, we use service control policies, and this means that we can eliminate certain areas of risk or configuration from happening entirely. This would be things like every Lambda must run in a VPC, no public S3 buckets, all queues must have a customer managed key, this sort of thing. In addition to this, we then adopt IAM permission boundaries. So any of our resources must be deployed with an appropriate permission boundary attached. And we've got different boundaries for Lambda, different boundary policy for step functions. What this does is define the maximum set of things that a step function can do. So if we take the pipes example, when we started, our policies wouldn't allow step functions. Whilst we can permit step functions globally, the policy attached to step functions wouldn't allow you to use it from a step function. Our engineering teams are able to collaborate with our cloud teams, make PRs against the configuration, have a conversation. If we agree something, yeah, we want to support step functions invoking pipes, we can expand the boundary policy to allow that. But it means we can give teams a huge amount of autonomy because we know they can't actually do things that we haven't deemed to be acceptable or haven't gone through the governance process. So this is really, really cool. We've got central management of our policies, but we can give teams complete freedom and autonomy to use the rest of the cloud. And the final service we use in this regard is IAM resource policies. So resource policies, I mentioned we have over 150 accounts. We've got many teams working in different account types on EKS, serverless accounts. By giving teams control of their own resource policies, they're able to configure fine-grained access controls for their services. So you can say, this team over here, we're going to let you call this specific endpoint in these environments. And this is a really, really great way to manage cross-account permissions for things like API Gateway or Kinesis. Yeah, highly recommended. If you're not using resource policies, it's absolutely something you should look into if you've got many workloads in many accounts. Okay, on to some examples. So you heard from Emily about managed service integrations. This is something we use extensively. And this allows you to directly integrate from something like step functions to many AWS services. And what it allows you to do is replace code that you run in Lambda that you ultimately have to build and maintain. SDK updates, node runtime updates, that sort of thing. And also, the more Lambdas you've got, the slower your build process is going to be, the slower your deployments are going to be, because Lambdas take time to build and deploy, right? If you can eliminate 50% of your Lambdas and replace them with managed service integrations, your build deployment process is going to speed up, and you're going to have happy developers. So one of the integrations we rely on heavily is direct DynamoDB integration, and what this allows you to do is write or update or delete or modify records in Dynamo without any Lambda code. It's pretty cool. If you go into the Step Functions Visual Workflow Studio, you can type in DynamoDB. It'll show you all of the things that you're able to invoke. You can drop it into your workflow, and you're then able to sort of determine the parameters that you pass into it directly, all through configuration, no code. So let's take a look at a specific example. In this example, we are, this is our original implementation. We've got some code. What we need to do is pass a bunch of data from the step functions context. So we've got some configuration to say, pass this data into the Lambda. We've then got code in the Lambda that then needs to read the data from the Lambda event, pass it into Dynamo and write it into the database. It's quite simple code, but we've now got we've got 2 points where we need to pass data, configuration, things can go wrong, and the Lambda we've got to build and maintain. We're able to replace this with a direct service integration. It looks very similar, but we've removed the exchange between step functions, configuration, and the Lambda, and we've removed the Lambda. And this is great. Right? It's magic. We've removed an entire Lambda, reduced the complexity of our application, and if you look at it here, you're also able. It also means you can break your logic down into more discrete steps, and it becomes very easy for someone to visualize the flow of data through your application, because you've got discrete steps. Step function is able to manage the retry and failure of your state machine in a way that's easily configurable. Okay, the second and final example I'm going to go through is our use of the transactional outbox pattern. So for one of the patterns we rely on heavily is atomic updates to our databases. Typically, we might want to create or update a data record and also send an event somewhere. And there's different ways you can do this. You could have a Lambda Lambda handler that writes to your database and then sends an event to a queue or bus. And this is okay, but what happens if you update the database and you can't write to the queue or that fails? You've now got an incomplete transaction. So the pattern we use is a transactional outbox. We use a single table design in Dynamo, so we can do these updates in a single atomic database commit that either succeeds or fails as a whole. And what this means is we have a table that contains both the data that we're updating and the events we want to send onwards. And when we're streaming data out to other systems, whether it's our data platform or other consumers, we're only really interested in the events, which means essentially we need to filter out half of the information that's in the table. And our regular pattern for this is to take a DynamoDB stream, which is a managed stream, change data capture stream, consume it with a Lambda function that performs the filtering, throw away the bits we don't care about, and then send the rest onwards to Kinesis. So this is an area, so you end up with just the events on Kinesis. This is an area where we thought Event Bridge Pipes would be a brilliant fit, because it's designed for this sort of integration and filtering. So in our original implementation, we had the Lambda right into Dynamo stream, and a Lambda that had to do filtering and transmission onwards to Kinesis. With pipes, we can completely eliminate this Lambda. Pipes allows you to take a source. In our case, it's the DynamoDB stream. It allows you to define a pattern-based filter. In this case, we've got a filter that looks for items that are prefixed with event. And then you're able to specify a target. In our case, it's the Kinesis stream you want to write to. And the great thing about pipes is that any of the, in addition to being a managed service, we've completely removed the Lambda. You also don't have to pay for the events that you filter out, which is quite a nice benefit. So in our case, the benefit of using pipes wasn't necessarily about cost. For us, it was reducing complexity and taking something that we had to manage and run ourselves and maintain and replacing it with a managed service. There is a cost benefit, but you need to think quite carefully if your reason for evolving in this way is around cost. So in this example, in our case, it worked out slightly cheaper to use pipes. The Lambda invocations cost 69 cents for a million events. We had quite a small Lambda using a batch size of 10 with not much memory, so it's fairly cheap. In pipes, by the time we've filtered out half the events, the number of invocations is halved, and the cost with pipes is 46 cents for a million events. So if you're thinking about, I'm going to adopt these things for cost optimization, you really need to understand your workload and work out if it's worth the effort. Right? There's quite a bit of development time. We saw a timeline of 4 months. Probably cost more than we're ever going to save to actually do the work. But for us, it wasn't about cost optimization. It was about simplifying our architecture and evolving to a place where we had less things to maintain and run. You can look at the original code here. We've got a Lambda function. It reads some events from the stream batch. We then need to filter them, map across the events, and then loop over them and send them to Kinesis. We're able to replace it with a simple managed service that has a configuration as code filter pattern, and we simply specify the target. Right, so it's a massive optimization and reduction in complexity. So, in summary from myself, you want to regularly consider how you're going to evolve your architecture. This is something you want to be thinking out about over a number of years and how you're going to do little steps along the way. Simplify your solution by evolving towards managed services. Build less Lambdas, have faster deploys, have a simpler operational overhead by moving to managed services. And if you're in an enterprise organization, make sure you've got the governance and processes set up to allow your teams to innovate and move quickly and evolve their architecture whilst maintaining the governance you need to do a professional job and look after your data. And with that, I'm going to hand back to Emily. There you are, who's going to close up.
Wonderful. Well, thank you so much, Tom. I love getting to hear about all of the amazing things that are happening at DVLA and how they're putting all of the concepts of evolving serverless architectures to practice. And so I appreciate what Tom had to share today, and thank you all also for joining us and for kicking off the morning with us. Hopefully you come away with some great things that you think about next time that you are designing a brand new application or looking at an existing application that you want to evolve and you want to continue to keep pace with the business, or the next time that you are applying for a driver's license. Hopefully you think back to some of the things that you've learned today. So thank you very much.